Okay. Is het goed? English, I guess. Okay. So there's been at least 3 people who asked me if I had stress to be back on stage after 18 months. And well, definitely it's less stress than the last time, because the last time I was giving the keynote at DevOps Days New York, and about 5 minutes before I started, somebody came up to me and said, Trump is going to lock down the airspace tonight. I was like, I want to get home. So that was the great disaster of 2020. What Christoph asked me to talk about today is the great fire of 2021. Does anybody know what I'm referring to? Yeah. A bunch of people. Basically, March 10th, Wednesday, our on-call engineer called me at 4 a.m. in the morning, and he said, our data center is on fire. I'm like, wow, what? Actually, I first misgrabbed my phone and didn't realize he was calling me, and then 5 minutes later he called me again, and by then I was slowly getting awake. And by the time I actually was going downstairs to find my laptop, I was like, it can't be on fire, it can't be that bad. It's not gonna be that bad, he's got some problems and he needs help, so he's escalating to somebody more senior who can help. But then I saw Twitter, and I read this, like, maybe there is a problem. Maybe there is an actual fire going on. And well, it's a really fun exercise to actually read the full thread, and the clueless comments from a number of people on there. We were like asking, so where are our backups? Like, you don't have backups, you're screwed. But yeah, that's for us, and definitely for the people who were on call then. I think for a bunch of people that was a life-changing moment. Not that much for me. Who am I? I'm Kris. I started my career, I'm old, as you can see I don't have that much hair left anymore. I started my career somewhere in '97 doing software development, Perl, Java, C, and then I started doing operations because I was the only one knowing how to rack a sun and how to build stuff. My current role is that the T typically stands for travel, but that hasn't been the fact for the past year and a half, so now it's mostly trolling. And CTO and open source consultant at Inuits. Most people, when they run into the Inuits problem, they curse at me on Twitter, because that has been the title of my blog for over a decade and a half. I started to organize a bunch of these conferences. Who's a DevOps engineer here? Okay, only smart people in the room. So I started DevOps Days together with Patrick Dubois. I started Config Management Camp with Toshan, and Load Days also with Toshan and a couple of other folks. So I tend to talk a lot about what we do with open source, how we build resilient infrastructure, how we build scalable infrastructure, how to collaborate with developers and all of those things. So enough about me. So that morning, that's what I got from news.net Craft, about 3.6 million websites across 500,000 domains went down. And this actually is a picture of what one of the buildings on that campus looked like after the fire. So when by 9 o'clock in the morning we started calling our CEO and sales folks like, our data center was on fire, here's the picture, they were like, oh fuck. But, so what do you do at 4 a.m.? You figure out what is really the problem? What is really the impact we have? Do we have customer-facing production services that are lost? What internal production services that we really, really need are actually gone? And which one do we need to recover in order to be able to spin up other things? And then we started figuring out what are the priorities, which services actually are generating 24/7 money, which ones are just off-hours toolings where we basically have time till 9 o'clock to get them up and running. And how are we going to do that? Are we going to spin up full clusters again? What's the thing? And actually we started looking at what happened is that a lot of our stacks, we have about 20 to 25 different customers in that setup. A lot of those were just not impacted. They had perfectly failed over to a different data center. They were still happily serving traffic and they were still humming happily, hopefully not having another failure, because one failure is okay, 2 failures to recover. We actually only had one virtual IP address which was supposed to host a service that failed to move to another data center. The API call to do so was failing and we actually couldn't do so. And then there was one small customer, one that actually was only having usage during office hours, where we did have a multi-data center strategy, but not a multi-campus strategy. So when we set up things, everything is in multiple data centers. So Strasbourg 1 and 2 are 2 different buildings, 2 different physical buildings. But that strategy starts failing when the fire department comes onto your site and says, we're going to just power off your whole campus, which is what happened then. And then the other impact we had was one disaster recovery site, which was in a totally different supplier, which was destroyed. So if there was another supplier who was going to go on fire, then we would potentially have problems. But all in all, not that much. To get that IP address moved again, we basically did a manual action. We used another public IP address, changed the DNS, updated everything. And that worked smooth for about 95% of that application, except for like one component where we just didn't own the DNS. And you know my mantra, everything is a fucking DNS problem. It took us about an hour to eventually find somebody, and I think we woke her up around 6:30 in the morning. We need the credentials for your DNS set up. Once that was fixed, things were happily running again. Apart from like a couple of customers that had hardware devices with fixed IP addresses rather than using the host names, which we found out afterwards, but they changed to actually using a host name and stuff started working. So that failing VIP learned us again that DNS still is one of the most critical things around. And then the other one was the customer we lost completely, which was spread over 2 Strasbourg data centers. What we did there was we spun up that stack again, and before 9 o'clock in the morning, we had restored their backups, spun up their whole infrastructure, and the platform was ready for use. We were still doing some performance tuning, which turned out to be an MTU problem, not a DNS problem. And for those who have read my Linux debugging troubleshooting 101, MTU is somewhere in the top 5. So we kind of knew that already. But yeah, if we hadn't told that customer, hey, like your data center was on fire, we totally had to rebuild everything, they wouldn't have noticed. So we lost about 1/10 of our infrastructure. We lost about 13 physical servers and 135 VMs. If that happens in your infrastructure today, are you going to survive? I see a couple of heads going no. Why not? I mean, it's really easy to survive, but it takes some time. Not even much money. The root cause is a funny one. The last update I got on this one was basically that there was maintenance on a UPS. And that got fire. And that caused the whole damage to happen. So you get a data center full with smoke, things start going downhill pretty fast. Customer facing, close to 0 impact. Internally, you know, like shoemaker who has the worst shoes or the bald hairdresser, a bunch of our internal systems, like our Nextcloud or GitLab, yeah, our Cube setups, which we're using anyhow, but we need to learn how crappy Cube is. So those things, they were gone. But by around 10 o'clock, 11 o'clock in the morning, they were back again up and running because we could re-provision them. Production didn't have impact, but a lot of our development and acceptance platforms where we don't have that full redundancy strategy, they were gone. But we could reboot them and redeploy them quickly again. But all in all, we survived. I mean, yes, it was a tough night. The on-call engineer and myself worked from 4 o'clock till around 12 o'clock. And then we basically said, somebody else can take over. We're going to sleep now because we are way too tired to think, way too tired to actually make good decisions. And then about 2-3 other engineers joined the team to actually reprovision and spin up new things and do everything like communication with customers. So not really that bad of an impact. So yeah, at 9 o'clock, we figured out there was one customer who was like, hey, but we still have a problem. And it turned out we did overlook one issue in the heat of the moment. There was one Gluster instance that didn't work correctly. But there was no data loss. There was basically, we mounted that as an NFS share on the disk on the application locally, and things started working again. That is, however, something you don't want to do for real production, because your cluster metadata now is gone. We needed to re-sync all the data back into the cluster, but we didn't lose any data. Till 3 months later, when some of our users were complaining that they couldn't access a couple of files. That was an application that had a long-standing bug where you should not be storing files into MySQL. So we were like, we've restored MySQL. We know their crappy application stores data and PDFs and stuff in MySQL. It should be fine. Turned out the developers actually had fixed that bug. They forgot to tell us that they were now using file system storage, which means those files were never backed up. Now the good thing there is the files in there were mostly resumes and things you actually can only keep for 3 months. So by then we were basically GDPR compliant again. So 9 o'clock. I was on my 10th cup of coffee. We were basically spinning up everything again. Everything was working. We were looking at, well, we're healthy again. What do we need to think about now? So a number of clusters had failed over to different data centers. Typically, we only make one backup on the active nodes. And that's always typically the primary node, O1. They're multi-master MySQL setups. There are elastic dumps with multiple nodes, but we only take one backup. We don't take backup on all the nodes. We started figuring out, like, do we have sufficient backup capacity on the things that have stayed over? Because tomorrow we still want to make a backup. Do we have sufficient disk space to actually keep going? That kind of things. We did. We provisioned a couple of additional disks, but that worked. And then we started planning, because we needed 10 physical servers again. We needed about 130 VMs again, because we lost them. But everybody wanted new hardware. And not only people that were hosted in OVH, other people also still needed hardware. So we had some spare hardware left for another platform in a totally different data center where we were planning other things. So we could kind of spin up things really fast, but not everything. We were thinking about spinning up things in the cloud, and we kind of made the huge mistake of trying to move things to another cloud provider. And we wasted about 6 hours there trying to figure out how to deal with their network redundancy, how to deal with their security, how to deal with their high availability, while we could actually reprovision and spin up new compute at our existing suppliers already. So that's something we're definitely never going to do again, like not try to get a totally new technology in place in the middle of such an outage. So we had that plan, we had re-provisioned everything we had stuff for, we had storage for again. And then came the third phase, like what else is missing? Our developers, what do they need so that our pipelines are going to run again, that we can actually promote from our development to our acceptance to our production environment? There was some rumors going on that we would be getting hardware back. It would be coming online again. When? In what state? Are they just going to power them on and those boxes are going to join clusters again, which are now actually already re-provisioned, so that could be potentially problematic. What was going to go? We didn't know. We were waiting for supplier to tell us like what's going to happen. In the end, we actually only got back 3 physical servers, so we really lost 10 completely. But what we were really spending most of our time up is planning, like, what's the priority for what needs to come back first? And what are the dependencies in getting things and finding new hardware? So that really was the most complex part, not about getting those things back up. What we also needed to do is that one customer who was at a different supplier who didn't have a disaster recovery side anymore, we need to talk with them and say, hey, how urgent is it for you to have a DR site? Because over the past 6 years, you never used it. They were like, we can take a smaller one, we can spin it up again. Eventually, we settled for spinning up a partial DR site for them on the available hardware, but I think after a week and a half, they were back in full force. The main problem there was availability for the hardware. But because we do everything with infrastructure as code, and because we have backups and we have data synchronization of everything they had from different data centers, this spinning up the new disaster recovery stack for them was kind of trivial. So how come this didn't hurt us this big? Why did we survive this? And why were we quite comfortable when we saw a lot of our colleagues and other companies basically going, I think a couple of companies, I've heard rumors of them going bankrupt because they completely lost everything. There's a bunch of others who really struggled for weeks to get back online and to really have their business up and running again. And we were like, yeah, okay, it's painful, it's not funny, I don't want to have this every week, but we prepared for this. We knew that something like this could potentially happen. And for me, the 4 key components that made us survive this is that we really use infrastructure as code. We have every single component in that infrastructure reproducible, and it's all automated. Second component is that our architecture for everything which is customer facing is by default redundant and replicated. I do not go to production with a service that is not tested, that is not resilient, that is not redundant. We have multiple backups of what we run, not only in the data center where the application runs, but also in an offsite data center, which turned out to be needed because we needed to be able to restore from other locations, because also latency would have killed us if we needed to restore from a data center in a different country. And the fact that our on-call team, when they get that one call a year, Christoph here is famous for actually being able to say, was I on call last week? While he was on call last week.
He's still on call now, and I'm not sure.
No, you gave your on call for about 2 days to a colleague and he felt it, but that's typically your karma. And you got the on call back after the IP cycling from that customer came back up. So yeah, no, typically when there is a problem, they typically escalate if they're like, I don't know how to deal with this anymore, please help me. And then we really were fast to talk to the one customer who was really impacted where we couldn't modify the DNS, like, you're gonna have a problem if we don't get your DNS credentials fast. Real infrastructure as code, in our case, means that we use desired state. Desired state means I want my infrastructure to look like this. I don't want to deploy it and say, hey, this is what it should look like, and then maybe it drifts away in 3 to 6 hours or days or months. No, we really have every 30 minutes, this is what it should look like. It's going to be enforced, which means if somebody makes a manual change, it's going to be overridden. If that fails, there's going to be alerts. If somebody turns off Puppet to automate things, there will be alerts sent. If it's off for over an hour, there will be alerts. We have 100% control over everything. And what I mean with no third parties involved is if we spin up an instance, if we spin an application, we don't need 5 other people to do the network, to do the disk provisioning, to do the security. We don't need another engineer to actually deploy the application. No. The code we wrote spins up the functional application the way it should be. And that's one person who can do that. It doesn't even need to be a system engineer, it can be a developer, it could be anybody. And they don't need any external help. We use Puppet really heavily, and we've done that for over a decade now, which means that a lot of the configuration that is being updated is done dynamically. You spin up a node, that node is a web server, that means you reconfigure the load balancer, you reconfigure the SSL certificates, you reconfigure the monitoring, the web server needs a database, you create the credentials, all of that is done completely automatically. And we also 100% deploy from our own local YUM repositories, which means that even if the internet is gone, even if a repository is gone, even if a package upstream is gone, we can still reprovision things. And everything is a pipeline. Everything is an automated process that goes through different phases and does all of that automated. And that level of infrastructure as code, that level of complete automation is what basically gave the engineers that were troubleshooting things like, okay, we need to spin up these 3 environments again, git commit, git push, it starts happening. And a couple of minutes or a couple of hours later, they start looking, yes, okay, it's there, it works, it's healthy again. But I didn't need to do any manual changes. They were just thinking about, okay, I need to move this to a different data center, which means I need to do this on this hardware, and that's about it. What is the hardware we have available? What are the resources we have available? Where can we spin this up? But that's the automation part. We do this in a cloud-native way since we started. We don't use the top brands because they're fucking expensive. I mean, we get bare metal for the price. AWS and Azure and Google give you a VM. But next to that, it's an API you call. You spin up hardware, 120 milliseconds later, you actually have a machine where you can talk to. Whether that is a VM, which is on EC2, or whether that is a physical machine in a data center in Paris or in Strasbourg or in Falkenstein or Helsinki, I don't care. I pay for it as long as I need it, and when I don't need it anymore, I cancel it and I stop paying for it. To me, that is what cloud is about. I don't know how many boxes we have, well, I kind of know, somewhere around 80, 90 physical boxes, about 700 to 800 VMs. But I don't need to see them in a data center. I don't need to go there and do all the cabling stuff. Everything we do is in code. The VM definitions, the storage definition, everything is in code. It's not in Terraform, it's in Puppet, but it doesn't matter. One day when we have infinite time, we'll refactor it to Terraform. Today I would do that from scratch in Terraform, but it's built in Puppet and it works. Which basically means we get a new box, Ansible sets it up, make sure it's in our internal network, make sure it's talking to our Puppet master, and then Puppet takes over for desired state. We actually have multiple suppliers where we do this. We can do this in OVH, we can do this in Hetzner, we can do this in, what's Packet called these days? We can do this in AWS, in Google, in whatever. Because once the VM is there, once we've spun it up and it's talking to our network, it's just another box. It doesn't matter. So this is a multi-cloud strategy by default. Customer DR sites are in another supplier. And what are the odds that both of those go down? Guess that then the internet is going to go really down, which is kind of what most of those people who go for AWS and Google assume, like, if Amazon is down, we don't care because then everybody is down. But yeah, if that's your HA strategy, why not? In those multi-data centers, multi-suppliers, we are multi-data center. We used to be Hetzner, then OVH came with a better network solution where we have Strasbourg, Gravelines, Roubaix, and a couple of others now. The huge difference for us between those two is the latency between the data centers. Within OVH, we don't see it, even inter-country. In Hetzner, you do see it. The latency between Helsinki, between Finland and Germany, it's noticeable. So there you need to be a little bit more careful about where you put resources and how you do things. But it works. Multi-data center, a bunch of these are SVG 1, 2, 3, 4, 5. For critical workloads, since March, we spread them over multiple cities. Because we don't want to have the situation again where the fire department says, hey, I'm going to just shut down the whole city, which could happen. The cloud native part is when I started playing with AWS ages ago, one of the things I really quickly learned is like, they're going to reboot my machines and trash them whenever they care and not when I care. So I need to have something resilient. I need to make sure that I prepare for failure, which means that everything we built is redundantly. HA proxy, CoralSync, Pacemaker, Linux HA, using the resources for the application level. So not depending on some kind of virtualization technology that does fake virtualization and fake HA for you, but actually having the applications redundant, actually having the applications aware that they are clustered. And lose VM or lose bare metal or even lose a data center, I used to say should not have impact, and by now I can actually say does not have impact because we've proven that it works. And we can rebootstrap things, and given that we have everything infrastructure as code and we can reprovision things, the only thing we need to care about from backups is all the user-generated data, if we know about the user-generated data, which sometimes still is a challenge. It's cloud agnostic. If I have hardware and the hardware runs Linux, it's going to work. I can figure out how many layers, but a VM is VM is VM. And if I need to do things in containers, I still need metal to run those containers in. Vendor-specific features, like, for example, the way how you move an IP address, public IP address, how you move routing, those are the ones which are feature flags. But we have support in our code base for all the ones we use. And they spin up, they get a parameter where they basically know, hey, I'm running on this kind of hardware, so I know this is my API to talk to for. And it doesn't matter if we have a customer who runs on OVH today and on Hetzner the day after, our Puppet code will figure out that it's a different data center and that's the API it's going to need to move that public IP around. So to us, really the cloud is just other people's computers we don't need to care about. And if one of those other people is AWS or Azure, yeah, sure, if the customer wants to pay more, I don't care. We split everything per customer and per project. So we don't have any all-in-one boxes where there's both the web server and the database and whatever queuing system on the same node. No, it's all single-purpose VMs. Some of them are really small, some of them are huge. The overhead, close to non-existing. We have single-purpose database clusters, single-purpose storage clusters, single-purpose load balancers, which means that if there's an outage, a technical issue, a real problem on the application level, say there's a storage cluster which is really suffering from I/O, it's only going to be impacted for that single customer, and not any other customer is going to have that problem. Because we have automation, because we do orchestration and all of those things, updating those things is not going to be a problem. If we improve functionality for one customer, it's a matter of a git push and a git update, and things will be updated on the other sides. So, yeah, clusters are multi-data center, and sometimes we do pin resources within one data center, but that typically for latency, but for production preferences are always on multi-data centers. One of the most challenging things for high availability is storage. We don't use any local storage in nodes anymore. If we know that there's local files access, it's going to be either Gluster or DRBD or Ceph. For MySQL, there's multi-master replication, there's pacemaker in front of it, so there's always one active node, there's always data written on multiple nodes. Things like Elastic are multiple nodes, multiple instances of Rabbit. Name the application we use, and we will be running it in high available mode. All of the VMs are boot from local storage, no shared storage. The shared storage would be a single point of failure. So there's no difference. Those VMs are disposable. We can re-provision them, and the data on them should be on a remote file system. So distribute it. One of the things, lots of people look at me puzzled when I say we don't use RAID. What's the use? All the data we care about is already spread over multiple nodes. Why still do that another time? I can use the disk to have more data, and I replicate my data over multiple disks. That and my really horror stories from the late 90s with Linux and software RAID basically being a pile of junk that never worked. And the hardware drivers never standardizing. But I think I stopped looking at that somewhere in 2002. So probably, I hope that has changed. But since then, I never saw use for RAID anymore, and apart from sometimes performance. But that's really sometimes. Backups are automated, both on-site and off-site, which means we do have backups 2 times, which was handy when we needed to spin up things in a completely different supplier. One of the things we learned years ago is our documentation. If your documentation is stored somewhere in your infrastructure and your infrastructure is down, then you don't know where to go. So our documentation is basically an mkdocs-based Git repository, which is publicly available on the known URLs to our team members. But most of them, and definitely everybody who's on call, has a local copy, and they can just run mkdocs locally and search and do everything what they need. The only thing they need to think about is kind of frequently update that repository. But they don't depend on remote things being available. They can just read the documentation locally. So what did we learn? Well, we were kind of afraid that we could not get sufficient hardware in time. And while our production setups were up and running before 9 o'clock and we had sufficient hardware, before we fully were up and running with all of our dev and acceptance platforms high available, before we actually had all of the resources again we needed, it took us a week and a half. Because the land rush to get new hardware from OVH, and actually the complexity we had at that was that we didn't want to have it in one physical data center. We also wanted to have it spread again. And we could have gone faster if we had said, just give us whatever hardware you have, and we don't care that it's all in the same rack, it's all in the same data center. But we were mainly waiting for hardware to become available in more data centers. Because otherwise we would go from, well, this was high available and spread over multiple data centers to, well, there's no real need in having 2 additional nodes in the same data center where we already have 2 nodes running, because then in 3 weeks we still need to move things around, and things was kind of already working. The other thing is the terminology, that a data center is not always sufficient. We need to look at, even if it's different buildings, even if it's a campus with data center 1, data center 2, data center 3, for some things we want multi-campus availability. We want that geographic spread. We really need to fix that shoemaker problem. Like, we really need to spend time on making a couple of our internal services that are not customer facing more redundant. I already knew that everything is a fucking DNS problem, but we've now started focusing more on having even more control over a couple of those customers' DNS, so that we really can fix that if they need to. At least 1 or 2 are really happy after we showed them this to give us access to those things. Not all of them, because some of them are large multinationals and it's just political that can't actually come up with a disclosable name of a customer, but yeah, the size of BMW, which is not a customer, but you're not gonna get the DNS access for BMW. That kind of level of customers. They're not really happy, their IT people, to give you that access, even though You have some application.bmw.com running, they still want to control that, which is understandable, but still, it means that you cannot guarantee everything. So, if I look back at this, for a lot of our people, this was really a lesson on why we do the things we do the way we do them. And a lot of people, and definitely salespeople and non-technical people, started understanding like, wait, if we didn't have this in place, we really would have been shitted. We really would have had a huge problem. So that's why I want to give these stories. Like, we survived this because we were prepared. And we know that a lot of people are absolutely not prepared for this, or just haven't even thought about this. AWS will go down. It does go down from time to time. They lose an availability zone. Are you prepared for that? Have you done real infrastructure as code? Stuff like that is things you need to think about. Last slide I have, but one is that nobody's in the room, but if they won't see that recording, I really want to thank them again for helping recover that day. It's also a team effort. It's not something you do just by yourself. When you have that kind of outage, you do call extra colleagues to help, because you lose control. You don't see everything yourself. My actual closing slide is, when we started the DevOps movement, this slide was one we used a lot. Developer has written some code, works on my machine, it's no problem now. And we never figured that that fire was really gonna happen, but it did. And I'm not gonna say that it can happen again next week, rather not, because it's still work and things you need to fix, but it's not gonna scare me. And in a way, I hope for a lot of you that you can get to a point where you basically can go to the office or work from home, whatever, and don't have to worry about a fire. That's something you want to think about. So, questions? How much time do we have? I had 40 minutes, so I did 40 minutes. Ooh. And that after a year and a half of no practice at all. No questions.
I think on the chat of the hackerspace, somebody posted a graph at the time of the fire of somebody's server with the temperature, and it was rising for like, I think 45 minutes, or there was speculation on how much data you could rescue if you notice that your data center is on fire. Do you have any thoughts on that?
I think we saw alerts from CPUs being overheated also, but I think before we even lost a couple of nodes. So I think if we really start looking at the alert history, we did a post-mortem in detail, but the first alerts we got were actually machines disappearing off the network.
I was thinking, still awake, right, as it was starting to happen, and I noticed in the chat my colleague who was on call noticing there seems to be some network glitches. It'll some network flapping. It'll probably pass, and then I went to sleep. But I think those network connections flapping was probably some network cables actually melting, and then it escalated from there.
Or some switches melting or going down. But there were some, I don't think we actually, because those are the metrics, when you've survived, you're like, yeah, okay, my graphite is back, I got my recent metrics, I got my application metrics, I got my historical metrics. I don't care about those last 3 hours of what temperature my CPU was. I know it went on fire, I know I'm not gonna see that machine again. But now you're basically saying next time a data center is on fire, you're going to go to bed again. That's what I just learned. Yeah. Okay. If there's no more questions.